Hello everyone, welcome to IIT and Gate classes. This is lecture 14 on TOC, and in this lecture we are going to start a new topic, that is PDA or push down automata. Let me tell you one thing, this is one of the most important topic in your TOC subject. Okay, so just after your FA was also very important topic, finite automata, and this is also one of the important topic. Okay, so PDA is an acceptance device for CFL. You should know this fact. Okay, and I think I have told you many times about this also, that PDA is an acceptance device for CFL. Okay, so we have two ways to prove L is CFL or not. Okay, so how to prove L is CFL? You have a language and you want to prove that it is a context-free language. Then there are two ways. First way is if you are able to construct a PDA accepting it, and second way you already know, that is context-free grammar generating it. Okay, so for a given L, if you are able to construct a context-free grammar generating it, then you will say that the given language is CFL. And if you are able, or you can say, or if you are able to construct a PDA accepting the same language L, then we will say that it is a CFL. Okay, so we have two ways to prove L is CFL, that is construct a PDA accepting it or construct a context-free grammar generating it. Just like your regular, if you, so there were three ways to prove language is regular or not. Okay, so what were the three ways? Please say with me. The first way was construct FA accepting it. Second way was construct a regular grammar generating it, and third way was construct a regular expression representing it. Okay, so we have three ways to represent, or you can say three ways to prove language is regular or not. Similarly, we have two ways to prove language is CFL or not. First way is construct a PDA, and second way is construct a context-free grammar. Okay. So what exactly is PDA? See, roughly I can say PDA is nothing but NFA with null move plus stack of infinite memory. So this is auxiliary memory. Auxiliary means extra memory. Okay, so we have NFA with null move. Okay, but what is NFA with null move? If you do not know, then please watch my previous lecture. You will got the idea. I think I do not remember the lecture number. I think it should be lecture number 3 or 4. Okay, in that lecture I have discussed in detail about NFA with null move, so you can watch that lecture. Okay, so NFA with null move and stack of infinite memory, this is known as PDA. So PDA consists of two things. First is NFA with null move, and second is stack of infinite memory. What is the use of this stack of infinite memory? Let me give you some example. So we have a language A par and B par n. You already know that it is a CFL, and we want to construct PDA accepting L. Of course, I have not given you exact idea what exactly PDA is and so on. So I'm not going into details, but just I will give you intuitive idea that how you will be able to construct PDA for A par and B par n, and what is the exact use of stack here. Okay, so let me give you some idea. See, let us because we said that we have NFA with null move, so uh, we will have a tape of infinite length which is divided into cells. Each cell store one symbol at a time. Okay, each and everything. See, whatever I'm saying here, I have already told you many times in FA chapter, okay, or the first chapter, that is FA, finite automata and regular languages. You can watch my previous videos. I think in lecture number 2 itself, I have told you about all these things. So please watch that if you are not able to follow it. So I will say it in a faster manner. Okay. So since it is NFA with null move, so it will have tape of infinite length divided into cells, just like FA only. The NFA with null move is finite automata only. So in FA, we have tape of infinite length divided into cells. Each cell store one symbol at a time. Okay, so let us take a string from this language. Say we have taken a string AAA triple B. Okay. Now each cell store one symbol at a time. We have a read head. Okay, one end of the read head is connected with tape, while another end is connected to final state control mechanism, which store the state of the machine and so on. You already know all these facts. So this is final state control mechanism, and initially we have stored initial state here. One end of this is a read head. One end of the read head is connected with tape, and another end is connected with final state control mechanism, which store the current state of the machine. Okay, so this is just like your NFA only. Now we have a stack here. Okay, we have a stack of infinite memory, and in this stack, see, stack is not empty. We have initial push down symbol known as Z0. Okay, Okay, why we are putting initial push down symbol, I will tell you about it after a few slides, but please just try to remember that we have initial push down symbol, that is Z naught. Okay, or forget about it. Okay, forget about it. I will tell you in detail in the in subsequent slides. Okay, I'm just giving you intuitive idea here. That's it. Okay, so let me say it this way. We have 3A's and 3B's. See here carefully. We have 3A's and 3B's, and we want to accept it. That means directly and directly we want to make comparisons between number of A's and number of B's. And if number of A's and number of B's are equal, then I will say that string is accepted. Otherwise, it is rejected by PDA. So how will you construct? I am giving you just intuitive idea. See, imagine these A's as red balls and B as blue balls. Okay, so we have 3 red balls. Okay, let me construct balls for you. So we have 3 red balls and 3 blue balls. 3 blue balls. Okay, and we have a box. Okay, we have a box here. How will you say, or how will you prove that number of red balls and number of blue balls are equal? So it's very easy task. You will put all the red balls in this bag. Okay, or you can say in this stack. So I will one by one I will read these balls from the tape and I will put them in the bag. Okay, so I am putting 3 red balls in the bag. Okay, yeah. Now your read head will be here now, because it has read all the red balls. Now read head will be placed here. Okay, forget about state and everything. Just focus here. I am just giving you intuitive idea. So now when blue balls came, what will you do? You will start cutting. Okay, so you will throw away blue ball and throw away red ball from here. Now next you will throw the next blue ball and next red ball, next blue ball and next red ball. That's it. So after so you will say that we have read entire string. We are here now, so we have read entire string. Okay, we have read the entire string, and your stack is also empty. Stack is also empty. That means what? String will be accepted. Okay, so this is the basic idea about your PDA. Okay, so PDA has NFA with null move and stack of infinite memory. So now you have got the idea that why we are using stack of infinite memory. Okay, just because we have kept here triple A triple B, we can keep here as A power 100, B power 100 also. So you have to push 100 red balls here, or we can keep A power 1 lakh, B power 1 lakh. So we have to put 1 lakh A's, or you can say 1 lakh red balls in this bag. Okay, so we need a bag of infinite memory, or you can say stack of infinite memory. Okay, I hope I have made the point clear to all of you. This was the basic intuitive idea of PDA. Okay, now let's jump to the next slide. Okay, so what is the formal definition of PDA? Now we are going to study it. PDA is a 7 tuple. Okay, PDA is a 7 tuple. FA was what? FA was 5 tuple. Okay, you already know all these things. If you are not able to follow all these things, or you do not know, then please watch my second, third lecture. In that lecture, I have explained all these things. Okay, so PDA is 7 tuple. So what are those 7 tuples? See, these 5 tuples are exactly same as that of FA. These 5 tuples are exactly same as that of FA, Q sigma delta Q naught F. And we have 2 extra tuple, that is tau and Z naught. Tau is set of stack symbols and Z naught is the initial push down symbol. Okay, initial push down symbol is that thing which I was explaining here. Now, a stack is not empty, we have Z naught and so on. Okay, that is the initial push down symbol, and why we are keeping it, I will tell you after few slides. Please do not worry about it. Okay, so tau is set of stack symbols. Okay, so what are these, and what is Z naught and so on? Don't worry, I will tell you. But let me focus here. First, let me focus here. Q sigma, Q naught F. These 4 tuple are exactly same as FA. Okay, so I'm not going to explain them again and again. Q is non-empty, finite set of states, and so on. Sigma is the input alphabet. That means the strings which we are giving to PDA, that those strings will be constructed from sigma and so on. Okay, if Q naught is your initial state, F is your final state, and so on. F is set of final state, we should say properly, and this can be empty also, and so on. Okay, F can be empty also. So I have told you many times, and I'm not going to repeat it again and again, but still I have repeated it. Okay, so it is same as FA. Now the difference in PDA lies in delta, tau, and Z naught. So let me explain it. But let me jump to next slide and tell you something. Okay, so see here, when we input string to PDA, then stack is not empty. Rather, it has one symbol called Z naught. Hence, Z naught is called initial push down symbol. I have already told you, but I have written in this slide so that you can note it down properly. Okay, please note it down. Please note it down properly. Okay, next, those symbols which can be stored on the tape constitute sigma. Okay, obviously. So whatever thing we are keeping on the tape, tape of infinite length, na? So we have tape of infinite length because of NFA, that is FA only. So that's why whatever symbols we can keep on this tape of infinite length, those constitute sigma. So directly indirectly, whatever we are keeping on tape, that is nothing but the input string to the PDA. So input string can be constructed from the symbols from sigma itself. Okay, I hope I have made the point clear. If you are not able to follow, please rewind the video and watch it again. Okay, so those symbols which can be stored on tape constitute sigma. Okay, next. Now next is, see here, those symbols which can be stored on the stack or null store constitute tau. Okay, so now you have got the difference between sigma and tau. Tau means what? Which can be stored on the stack. Whatever symbol you are storing on the stack, that constitute tau. Whatever symbol you are storing on the tape, that constitutes sigma. Okay, I hope I have made the point clear. And please note it down. This is very, very important point. You will get confused. Okay, so please note it down carefully. What we are saying is Z not belong to tau, but Z not does not belong to sigma. Okay, so Z not cannot be stored on the tape. Please note it down carefully. This is the tape now, so you cannot keep Z not here, but we have to keep Z not here. Okay, and whatever symbols we are storing on the stack, that constitute tau, and whatever we are storing on the tape, that constitutes sigma. Okay, I have repeated many times. I hope I have made the point clear to all of you. So please note it down, all these points very carefully. I am putting everything on one slide so that you can note it down. Okay, please note it down carefully. Okay, next slide. Next is your heart of machine, that is transition function delta. Okay, in FA also I said that heart of machine is delta. So in PDA also, obviously heart of machine is your transition function delta, because it will tell us about how exactly PDA functions. Okay, so as I have already told you, PDA consists of tape of infinite length divided into cells. One cell store one symbol at a time. Okay, and we have a stack of infinite memory, and we have a read head. One end of the read head is connected with the tape, and another end is connected with finite state control mechanism, which store the initial state. Initially we are at initial state, that's why we are keeping here initial state. Okay, so see here, stack is not empty. Okay, we are keeping initial push down symbol, that is Z naught. So now the question arises, PDA is at state Q naught, and it is going to read something. Say it has read A from the tape. So what we will say, PDA is at any state Q naught. It has read symbol A from the tape and Z naught from the stack. Where it will go? That question will be answered by delta. So I will say, let us suppose, obviously it will move here now, one step ahead, and it is, I will say that it is going to state number Q1. Okay, so and the symbol here is B. So this is one of the move. So how exactly we are going to write delta? I will say delta, we are at a state Q naught. From the tape we have read A, from the stack we have read Z naught. Okay, and we will say that we have jumped to Q1. Okay, and after jumping to Q1, one question should also come to your mind, that what we have exactly pushed onto the stack. So this is our responsibility. Whatever we want, we can push. Or if you do not want to push anything, you can say that we have indirectly, you will say that we have pushed null. Null means what? Nothing. So if you do not want to push anything, you can say that we have pushed null. This is also allowed. Okay, but for the sake of simplicity, I will show you all these things later. But for the sake of simplicity, I will say that I am putting a Z naught. So what does this mean? So when I apply this move, where exactly, what will be the situation of the PDA? So initially Q naught, we have read A. Now we are jumping to Q1 state. So finite state control mechanism will be here. And A Z naught is pushed onto the stack. So A and Z naught will be pushed. Okay, and let me tell you one thing. Many students got confused here. So see, this stack is of infinite memory. This stack is of infinite memory. And imagine that it is very deep. Imagine that this stack is very deep. So you cannot see from here that, see, this is Z naught and so on. So directly, indirectly, I want to say that you will read this Z naught after popping it. Without popping, you cannot read it, because I am assuming that this stack is of infinite memory and it is very, very deep. So you cannot see, you are here, and you cannot say that, see, I have read, I have seen Z naught here and so on. You cannot say like that. So because it is very, very deep, you cannot see with your eyes. So you have to pop it, and then you can read it. Okay, so you have to pop it, then you can read it. So when I apply this move, now this is very important point. Please note it down, otherwise you will get confused. Okay, this is very important point. So whenever I said that Q naught A Z naught, that means what you have read A from the tape, and simultaneously you have read Z naught from the stack itself. Whenever you have read Z naught, that means what you have popped Z naught from the stack. Now you are saying that you are pushing A Z naught to the stack. That means what? That means what? You are keeping A as well as Z naught on the stack. Okay, in sequence, right? In sequence. Okay, because it is a stack now, sequence will matter. So A Z naught means what? A will be above, Z naught will be down. Okay, so this is your an example of transition function. So let me give you one more idea. Okay, so we are at Q1, we have read B from the tape, and what we are going to read from stack? Obviously, we are going to read A from the stack. Okay, so you can add only one symbol at a time. Please note it down. This is very important fact. You can read only one symbol from the stack, and you can read only one symbol from the tape at a time. Okay, so we are at Q1. So let me write move. We are at Q1. From the tape, we have read B. From the stack, you have read A, and we are jumping to state say Q2, and we are pushing say X, Y on the stack. So after this move, what do you think? What will be our you can say PDA? How PDA will look like? See, I will after applying this move, since you have read B from the tape, so you will move one symbol to the right. Read head will move one symbol to the right. Okay, and it will store state Q2. Okay, and since you have read A from the stack, so you have read A after popping it. Okay, now you are pushing X, Y onto the stack. So you will push X and Y onto the stack in sequence. Like this, you have to keep it in mind. Keep it things in mind. Okay. So please note it down carefully. And let me show you one more thing, because I have said NFA with null move. See the previous slide. I have told NFA with null move. That means null move is allowed. Null moves means what? You won't read anything from the tape. This is also allowed. So let me say here we have say symbol C. Okay, so Q2 on C. So on Q2 you have to read C now. But I will say if we want a null move, then how I will write? I will say delta Q2 null X. That will be equal to say Q3 AB, like this. Okay, so what this move means? What this move means? I will say we are at Q2. We are reading nothing from the tape. Since we have read nothing from the tape, so read head will not move here. It will be placed here only because it has not read this C. Okay, and we have read X from the stack. We are going to Q3. So here I will remove Q2 and I will put Q3, and A and B are pushed onto the stack. And since we have read X from the stack, so you have to pop it. Okay, you have to pop X, and you have to push AB onto the stack. AB onto the stack. Okay, so it's see, I actually by chance I have kept two symbols, so you can keep any number of symbols. So I can say here C also. So you can push ABC also. So you can push any number of symbols onto the stack. Okay, so you have pushed ABC. So let me write them in proper sequence: A, B, and C. So main thing is you can push any number of symbols onto the stack also. So let me write a generalized your transition function delta. So it will be like this. See, we are PDA is at any state Q, and you are reading anything from the tape. We are reading anything from tape means what? We are reading that means sigma. Na? Okay, and you can read null also. That means what you there is a choice that you reading null. I'm saying it roughly. Exact should be that we are reading nothing from the tape. So reading nothing from the tape means what? Directly, indirectly reading null. Okay, yeah, and from the stack you have to read something, or you can say exactly one symbol from the stack, and stack symbols are represented by tau. Okay, so now you are going to some state, and you can push any number of symbols onto the stack. Okay, so this is your intuitive way, or you can say rough way of writing delta, or you can say generalized way. Okay, roughly I am writing it, because this is what exactly will be the delta, that depends on NDPD or DPDA. So I am just giving you idea that we are at PDA is at any state Q, and PDA is reading something from the tape. Something from the tape means what? It is reading sigma, and exactly one symbol from the tape. Okay, and null means what? You have read nothing from the tape. This is also allowed, and exactly one symbol from the stack, and we are going to some state q and pushing any number of symbols onto the stack. Tau star means any number of symbols onto the stack. Okay, so how many symbols we can read from the stack? Exactly one symbol. Exactly one symbol you have to read. Please note it down carefully. Exactly one symbol you have to read. Directly indirectly means what? Initial state. If you are at initial state, if we do not keep this z naught here, see here carefully, if we do not keep z naught here, what should be the move? You should say q naught a null. No, we cannot say q naught a null. Null means what? You have read nothing from the stack. But no, it is not the delta. Delta is saying that you have to read something from the stack. That's why we have kept z naught. Okay, so I hope I have made the point clear. That's why we are keeping z naught in the stack initially. Or why initial push down symbol is needed? Because this is the restriction on PDA that you have to read something from the stack. Okay, or you can say exactly one symbol from the stack. Okay, so or we are at any state q. There is a choice from the tape that you read something from the tape or you read nothing from the tape, but you have to read something from the stack, and you will go to some state and push as many symbols as you want onto the stack. So stack symbols are represented by tau. That's why I'm saying it as tau star. Okay, I hope I have made the point clear to all of you. Okay, now let's jump to the next slide. But let me put everything on one slide so that you can note it down carefully. Okay, so let me put everything on one slide. Yeah, just keep note it down. Now I'm jumping to next slide. See here carefully, I have written few points. These are very important points. See here, read at most one symbol from the tape. At most one symbol means what? You are free to read nothing from the tape, or you have to read one symbol from the tape. So that means what? 0 or 1. That means what? At most one symbol from the tape. Let me underline it properly. At most one symbol from the tape, exactly one symbol from the stack, and push any number of symbols onto the stack. Push any number of symbols onto the stack means what? Tau star, and go to any state. Okay, so this is all about your delta. Okay, yeah, next point. Since we have read exactly one symbol from the stack in every move, so initially we put z naught in the stack. Okay, so this is the reason that why we are keeping z naught in the stack. Okay, let me read it again for you. Since we have read exactly one symbol from the stack in every move, exactly one symbol, so initially we put z naught in the stack. Okay, that's it. So so see, just like FA, we have two types of FA, NFA and DFA. Here also we have two types of PDAs. Okay, we have two types. Oh, sorry, we have two types of PDAs, that is Dpda and NDPda. For Dpda, transition function is like this: Q cross sigma union L cross tau implies Q tau star. Okay, for NDPda, it is Q cross sigma union L cross tau implies finite subset of Q tau star. That means we can move to more than one state also. Okay, more than one state means what? We have a choice. Just like NFA, we have choice. So let me give you some intuitive idea for NDPda. Okay, so see here. Okay, see here. If we are writing move for NDPda, we can write like this also: Q naught A Z naught, Q1 A Z naught, comma Q2 A Z naught, yeah, comma Q2 B Z naught. Okay, so what does this mean? Whenever PDA is at state Q naught and symbol A is read from the tape and Z naught is read from the stack, then there is a choice. Choice means PDA can go to Q1 state and A Z naught can be pushed onto the stack, or PDA can go to state Q2 and B Z naught is pushed onto the stack. So there is a choice. So whenever we have a choice, that is the basic meaning of non-determinism. Okay, so that will this is an example of NDPda move. Okay, that's it. Yeah, so now let me tell you something. This is the mathematical definition of Dpda, and this is your English statement. So please note down these statements very carefully. These are very important statements. Okay, and they will confuse you. So let me read it out for you. So the Pda is deterministic if and only if following two conditions are satisfied. So you have to satisfy both these conditions. So first condition is for all q in q and for all a in tau, if q null a is non-empty, then q b a must be empty for all b in sigma. This is the first condition. So null a is non-empty. See, this is known as null move. This is known as null move. Null move means what? You are reading nothing from the tape. If you are reading nothing from the tape, that is null move. And this is known as true move. True move means what? You are reading something from the tape. Okay. Yeah. So directly, indirectly, I am saying if you have a null move, then please do not apply true move. If you have true move, then do not apply null. This is the basic definition of this is the basic meaning of the first point. And see here carefully. See here carefully. For all Q in Q, for all A in tau. See here, A and A are matching now. A and A are matching. So let me tell you something that why this is not allowed. I am just giving you intuitive idea. See here carefully. Okay. So see here carefully. See, I will say. Okay, I will say. Okay, so okay. So let me make a new diagram for you. Okay, that will be much better option. Here it will become messy. Okay, so let me make a proper fresh diagram for you. See, this is a tape of infinite length divided into cells. One cell store one symbol at a time. We have a read head. We have finite state control mechanism. Read head is placed on the first symbol. You have read A from the tape, and we are at Q0. And initially we have kept Z0 in the stack. So now see here carefully. If I say delta Q0 A Z0, it means we are going to state Q1 A Z0. And here I am applying Q0 null Z0, that is equal to Q2 B Z0. Okay, so see here, see, this is the basic meaning. Now, if we have moves like this is the basic meaning that it won't be Dpda, it will become NDPDA. Why these moves are making this PDA as NDPDA? Just because we have a choice here. You will say, sir, where is the choice? Let me show you something here. See, I will say PDA is at state Q0. From the stack, it has read Z0. Now there is a choice that you read A from the tape or you read nothing from the tape. If you read A from the tape, you will go to state Q1 and A Z0 will be pushed onto the stack. And if you read nothing from the tape, you will go to state Q2 and B Z0 will be pushed onto the stack. Okay, so I hope I have made the point clear to all of you that there is a choice here. Why there is a choice? Whenever PDA is at state Q0 and Z0 is read from the stack, then PDA has a choice that it got excited. Excited in the sense it is not reading anything from the tape. It got excited, just like a kid. Kid gets excited, na? Then in excitement they will make mistakes. So here also PDA is making a mistake that PDA is at state Q0, and just like a kid, as soon as it read Z0, it got excited and it said that I am not reading anything from the tape and I am moving to state Q2 and B Z0 will be pushed onto the stack. And if this PDA is behaving maturely, or if PDA is a mature kid, then it will say that I am at Q0, and as soon as it read Z0 from the stack, it will say okay, I have read Z0, nothing, no need to worry. I will first read this A from the tape, and then I will say that I will move to Q1 and A Z0 will be pushed onto the stack. So now this PDA has a choice. That means it can behave like a immature kid or it can behave like a mature person. If it behave like a mature person, then this will be the move, and if it behaves like a kid, then this will be the move. Okay, so now I think you have got the idea that why we have a choice here. Okay, so now see here carefully, you will get the idea. For all Q in Q and for all A in tau, if if Q null A is non-empty, then Q P A must be empty. That means if we have a null move, then true move should not be present, and if we have a true move, then null move should not be present. Okay, please note it down carefully, you will get the idea. Okay, now next is a very basic thing, that there must be a unique move for each sigma, tau and Q combination, and no need to give all possible move. This is very important point. In case of Dfa, we have to give each and every possible move. Now see, if sigma is A comma B, okay, in case of Dfa, sigma is A comma B, we are at Q0, then I used to say that you have to give move for A also and you have to give move for B also. Okay, that configuration was not allowed in case of Dfa, but it was allowed in NFA. But in Dpda, that configuration is also allowed. That's why I have said that no need to give all possible moves. That means on state Q0, There is no compulsion that you have to read A also and you have to read B also. Okay. The only thing is there should be unique moves, and if null move is present, then true move must not be present. If true move is present, then null move should not be present. That's it. Okay. So these are the two conditions for Dpda. Okay. I hope I have made the point clear to all of you. And if one of the condition is not satisfied, or if both conditions are not satisfied, then that will become NDPDA. And I will say one more important thing, that every Dpda is NDPDA, but every NDPDA is not Dpda. Okay, so even if both conditions are satisfied, we will say that it is Dpda, and by definition we can say that it is NDPDA also, because what here what we have said, finite subset of Q tau star, and here we have said Q tau star. That means what, if you have everywhere, see, this definition is also allowing unique moves. Okay, this definition is not saying that you have to keep more than one move and so on. We have said here finite subset of Q tau star. So obviously unique moves are allowed here also. So every Dpda is NDPDA, but every NDPDA is not Dpda. Okay, and by default Pda means NDPDA only. It is similar to Fa only. Every, see, in chapter 1 I have already told you that every NFA, sorry, every DFA is NFA, but vice versa not true. Every DFA is NFA, but vice versa not true. But vice versa not true. Here also I will say every every Dpda, every Dpda is NDPDA, but vice versa not true. And in FA we said that by default FA means what? NFA. Similarly here also by default PDA means NDPDA, because NDPDA is more general, na? That's why we are saying it like this. By default FA means NFA, by default PDA means NDPDA. Okay, and one very important point, we have shown you, I have shown you algorithm for NFA to DFA conversion. Okay, I hope you remember it. NFA to DFA conversion algorithm I have already shown you, but no such algorithm here. Okay, so directly indirectly I want to say, see, NFA to DFA conversion algorithm. So because we have algorithm for NFA to DFA conversion, that means every NFA can be converted to equivalent DFA. That means what, in terms of power, NFA and DFA have same power. NFA and DFA same power. NFA is equal to DFA in terms of power. Okay, but please note it down carefully. This is very important point. But there is no algorithm, no algo for NDPDA to Dpda conversion. For NDPDA to Dpda conversion, there is no algorithm. Okay, and why we do not have any algorithm? Because in terms of power, NDPDA is more powerful than Dpda. Is more powerful. So powerful means what? It has more muscles. No, power means there are some CFLs which cannot be accepted by Dpda but can be accepted by NDPDA. So power, see, I am writing it in neat and clean manner. In terms of power, I am saying now. So power means what? There exist CFLs for which NDPDA, for which Dpda cannot be constructed. Okay, there exist CFLs for which Dpda can't be constructed. Yeah, or let me write in the shortcut manner because it will waste a lot of time. Okay, so Dpda cannot be constructed, but NDPDA can be constructed. Okay, please note it down carefully. So there exist CFLs for which Dpda cannot be constructed, but NDPDA can be constructed. So this is the basic meaning, that NDPDA is more powerful than Dpda. Since NDPDA is more powerful than Dpda, so obviously we cannot have any algorithm which can convert NDPDA to Dpda. Because if we have algorithm, then it then directly and indirectly it means that every NDPDA can be converted to Dpda. Okay, which is the contradiction of this fact. Okay, I hope I have made the point clear. Okay, and if you are not able to follow, don't worry. Okay, I will give you a few examples, then you will get this idea. Okay, why I'm saying that NDPD is more powerful than DPDA and so on. I will show you some examples. I will show you some CFLs for which NDPD can be designed, but DPDA cannot be designed. Okay, I hope I have made the point clear. Please note it down. All these facts are very, very important. Okay, let me put everything in one slide so that you can note it down carefully. Okay, so I think everything cannot come on one slide. Okay, so try to note it down till here. Okay, see my hand. Try to note it down till here. Then note it down these things. Okay, yeah. So now I'm jumping to the next slide. Okay, so see the major concern of FA is acceptance or rejection of string, na? Just like FA PDA, na? So I should write here PDA. So major concern of PDA is acceptance or rejection of string, because it is an acceptance device. So acceptance of string, okay, can be done in two ways in case of PDA. Okay, in case of FA we have only one thing, only one way, na? That starting from initial state, after reading entire input string, FA is at any one of the final state, then string was accepted. So this was by a final state. There was only one way. But in case of PDA, we have two ways of acceptance. See here, we have two ways of acceptance. First is final state and second is null store. Final state means starting from initial state, as I have already told you, starting from initial state, after reading entire input string, PDA is at any one of the final state. Then we will say that the given string is accepted by PDA. What about my null store? Null store is the another name for stack. Null store or stack, one and the same thing. Okay, yeah. So null store means what? Starting from initial state, after reading entire input string, null store or stack must be empty. Must be empty means not even Z0 should be kept in the stack. Okay, nothing should be there in the stack. So please note it down carefully. Pause the video and try to note it down. Okay, I hope you all have noted down. Yeah, and please see here, we are not concerned with the state of the machine. So and in fact, in case of null store, there is no need of final state. No need of final state, because we are not concerned with the state, we are concerned with the stack. That means stack should be empty. Okay, so acceptance by null store means starting from initial state, after reading entire input string, null store stack must be empty, and in the bracket I should write regardless of the state. Regardless of the state. State can be PDA can be in any state, regardless of state. Okay, yeah. And please note it down this fact also. This is very, very important. Of course, I'm not going into detail because this is a basic course, so I'm not going into the detail, but please note it down carefully. DPDA with final state is more powerful than DPDA with null store. Okay, see, we have two ways of acceptance now. Acceptance of string, we have two ways, final state and null store. Okay, so in case of DPDA, final state is more powerful than null store. That means there are some CFLs which can be accepted by DPDA with final state, but cannot be accepted by DPDA with null store. We have two ways of acceptance, by final state as well as null store. So final state way of accepting string by final state is more powerful in case of DPDA than a way of accepting string by null store in DPDA. Okay, so final state is more powerful than null store. And in case of NDPDA, see here carefully, in case of NDPDA, final state is equal to null store in terms of power. That means what? In case of NDPDA, if we are able to construct NDPDA which is accepting string by final state, then obviously we can construct NDPDA with null store also for the same language. Okay, if for L, let me say it properly, if for any language L we are able to construct NDPDA which is accepting all the strings of L by final state, then for same L we will be able to construct NDPDA with null store which will accept all the strings in L. Okay, that is the basic meaning. So both are equally powerful, but final state is more powerful than null store in case of DPDA. Please note it down carefully. Okay, yeah. So let me put everything on one slide so that you can note it down everything. Okay, yeah, I think it should be visible to all of you. Please note it down, and I'm jumping to next slide. I hope you all have noted down. Yeah. So now we are jumping to the questions. Okay. See, the very first question is, okay, very first question is, L is a power n, b power n is greater than or equal to 0. Construct PDA accepting L by null store. Okay, so I am constructing PDA accepting L by null store. So see here carefully, A power n and B power n. So n is greater than equal to 1. Now that means what? Null string won't be accepted. So smallest string will be AB, then double A double B, then triple A triple B, and so on. Okay, so language will be like this. Now language will consist of AB, then double A double B, then triple A triple B, and so on. Okay, so how to construct PDA for it? Okay, so let me do construction. See, we are initially at Q0. Okay, and as soon as we read A, okay, so we okay, so actually now there are two ways for construction of PDA. Let me show you a way which will be which you will think that it is simple, but actually it is not simple. It will become complex gradually as you jump to tougher questions. So this is a very easy question, and for this easy question I can design with the help of delta moves also. So let me show you or let me give you some idea. See, initially, okay, or let me take a string. That is the best way to explain. We have a string triple A triple B. Initially we are at state Q0, and in the stack we are having Z0. So what should you do? See, I will say delta. Initially we are at Q0. We have read A from the tape, Z0 from the stack. What should we do? I have already given you intuitive idea that imagine A's as red balls and B's as blue balls. So you will put all the red balls in the stack, and when blue balls came, then you will do cutting. Okay, so let me push each and every A into the stack. So how will you push? I will say delta Q0 A Z0. That means Q0 A Z0. We are not changing the state just because Q0, the mindset of Q0 is pushing. Okay, you have to push into the stack. Since we are pushing symbols onto the stack, so we are not changing the state. Okay, so Q0, we are at Q0 itself, and whenever A is dead from the stack we have Z0, then Q0 A Z0. That means what? This A will be pushed onto the stack. Now we are at Q0 only, and we are reading this A. So again we have to give a move, and that move will be what? Okay, so see, we are at here now, Q0 A, and from the stack we are reading A. So write the move properly. We will say Q0 on reading A from tape and on reading A from the stack. Where you are going? We are going to Q0 only. We will stay on Q0 only, and we will push double A onto the stack. Why we are pushing double A? See here carefully. As soon as you apply this move, okay, as soon as you apply this move, this A is read from the stack. So obviously this A will go away. This A will go away. Now we are at Q0 only, and we are pushing double A. Why? Because see, we have to push this A, and the A which we have popped from the stack, we have to push that A also. So that's why we are pushing double A onto the stack. Okay, now see here carefully. We will jump to Q0 only. We are at Q0 only, and read head will move one symbol to the right. Now we are at Q0. We have read A from the tape, and we have read A from the stack. Since you have read A from the stack, you have popped it, and only then you have read it. So move will be what? We are at state Q0. We have read A from the tape, and we have read A from the stack. Now we will jump to Q0 only, and double A will be pushed onto the stack. That means what? You will push this A onto the stack as well as the A which we have already popped. So you have to push double A onto the stack. So we will push double A onto the stack. Okay. Now we are in Q0 only. Okay. Similarly, if we have 4 A's, 5 A's, 6 A's, and so on, we can have any number of A's. Okay, and all these A will be pushed onto the stack. Okay. Now come the B part. Now we are at Q0 only. Now we are at Q0 only. See here carefully. After reading this A, read head will move here. So we will be at Q0 only. On Q0 we have read B from the tape, and we have read A from the stack. So where we should go? So now our mindset is changed. That means what? Now you have to do cutting. So for cutting, you have to jump to a new state. Let us label that state as Q1. So I will say on Q0, whenever you read B from the tape and you read A from the stack, then you will jump to state Q1. And because we are doing cutting now, so we will not push anything onto the stack, or indirectly we will say that we have pushed null onto the stack. Null means what? Nothing has been pushed onto the stack. Okay, so I hope I have made the point clear. So because of this move, what I will say, on Q0 we have read B from the tape and we have read A from the stack. So this A will be popped off, because without popping we cannot read it. Now we are jumping to state Q1 and nothing is pushed onto the stack. So we are jumping to Q1. Okay, so state is changed, and obviously read head will move one position to the right because it has read this B. So read head is on one position right, that is on B, and we are at Q1 and we are reading B from the tape, and we are reading B from the tape, and we are reading A from the stack. See, we do not have any move here, so write that move properly. I will say we are at Q1. From the tape we have read B, from the stack we have read A. We will move to state Q1 only, and we will push nothing onto the stack. Why we have not changed the state? Because our mindset is not changed. Our mindset is still for cutting only. Okay, from Q0 your Q0 mindset was pushing, and Q1 mindset is cutting. Okay, or you can say popping. Okay, so now we have read this B from the tape and we have read A from the stack. So how we have read this A? After popping. Now, okay, so see, this move is completed. Now again it will move one position to the right. State will be Q1 only, because this is obvious now. See here carefully. See, I need not explain it again and again. There is no need to explain everything again and again because video will be a bit lengthy. Okay, so see, on Q1 we have read B, we have A here now. On Q1 we have read B and we have read A from the stack. We have this move, so we will move to Q1 only. Okay, because we have read this B from the tape, so read head will move one position to the right and we will stay on Q1 only. And why we have stayed in Q1? Why we have stayed in Q1? Because we have applied this move. Okay, that's it. So now, okay, and this A was already popped from the stack. Okay, so now on Q1 we have read this B, and from the stack we have read this A. Again the same move. Okay, from Q1 we have read this B, and from stack we have read A. Again the same move. That means Q1 null. So that means what? Read head will be here and there is nothing here, so no problem. So we are at Q1 and there is nothing on the tape. Okay, and this A is already popped off. Okay, why this A is already popped off? Because we have applied this move. Okay, now what should be the move? What should be the move on Q1? What is present here? We really don't know, and we really are not concerned what exactly is present here. We will directly say we are at Q1. As soon as you read Z0 from the stack, this means what? Stack is going to be empty. So what should be our concern? We should say that stack is empty, so there should be nothing on the tape left. There should be nothing left onto the tape. So I will write move directly, that is on say Q1. You will read nothing from the stack, and sorry, you will read nothing from the tape, and you will read Z0 from the stack. Then you will go to state. Say it's your wish that you want to change state or not. We are accepting by null store now, so it's your wish. Do you want to change state or not? So let me change state for you, no problem. And since you are making this FA with null store, so you will push nothing onto the stack. That means what? Stack should be empty. Okay, so I hope I have made the point clear to all of you. This is your final Dpda, which is accepting what? Which is accepting a power n, b power n is greater than or equal to 1 by null store. Okay, so let me show you in a faster manner so that you got the idea. First of all, please note it down carefully. Please note it down everything carefully. Now I'm showing you again that why this DFA is correct. Okay, let me sorry, why this Dpda is correct. Let me show you again. Okay, in a very simple manner. and enough on a faster pace. Okay, let me show you. Okay, see here. See, these are the moves, and let me show you that these moves are functioning correctly or not. So let me put 4 A's and 4 B's. Okay, and this is our stack. Initially we have Z0, and here we have Q0. So what first question will be? We are at Q0, read A from the tape and Z0 from the stack. We will say Q0 A Z0, Q0 A Z0. That means what? This A and Z0 will be pushed onto the stack, and state will be Q0 only, because we have read this A. Because we have read this A, so read head will move one position to the right. Okay. Now see here, Q0 A. See here, Q0 A, Q0 A. That means what? This A will also be pushed onto the stack. So I'm not doing it again and again just to save the time, because we have applied this move Q0 A. That means what? This A should be popped off, and then we are pushing double A onto the stack. You can do like this as your homework. I am just showing you that we are pushing. That's it. Okay, so whenever you see this type of move, Q0 A, Q0 double A, that means what? This A as well as this A, both A's are pushed onto the stack. Okay, just try to remember this thing. Okay, so we are at Q0 only, and we have at this A again. We have to push. So now you have got the idea that we are pushing. As soon as we read A from the tape and we read A from the stack, we are just pushing A's. That's it. So third A is pushed. Now we are at Q0 only. This A is read, so fourth A will be pushed. Now after pushing all these A's, okay, so still we are at Q0 only, and we have read this B. Now cutting will start. So A and B, this will be cut, and we will move to the state Q1, because now cutting has been started. So we will move to state Q1. Q1 B A, this B cut. Now we are at Q1 only. Q1 B A, this cut. We are at Q1 B A, cut and cut. Now we are here and in state Q1 only, and we are not concerned what exactly is present here. We will directly say we are at Q1. Z0 is read from the stack. What does this mean? PDA will got excited. It will read nothing from here. Since we are reading nothing from here, so I will say that leave it. Okay, so we are not concerned what exactly is present here. Please do not say, please, this is a very big misconception in many students. They will say, and unfortunately many teachers told these things in wrong manner. They will say that we are at Q1, null is read from the tape. Please do not say null is read from the tape. Null is nothing. So you will say nothing is read from the tape. Okay, and even I have seen many teachers, they make here null. They say after here after all B's are over, we have a null here, and they will say we are at Q1, we have read null from the tape, and we have read Z0 from the stack. Then we will push null onto the stack and so on. They are treating null as a symbol. No. This is a very big misconception. Null is not a symbol. You will say we have read nothing from the tape. Okay, so what exactly is present here, we are not concerned, and we will say we are at Q1, we have read nothing from the tape, so we will remain here only. Since we have read nothing from the tape, we will remain here only. We are not jumping anywhere else. Okay, or you can say we are not jumping one position to the right, because we have not read anything from this from the tape. We will remain here only, and I will say that on Q1 we have read nothing from the tape and Z0 from the stack, and we will say we will jump to Q2 and nothing will be pushed onto the stack. We will jump to Q2 and nothing will be pushed onto the stack. So Q1, we will cut Q1, and we will say here we are jump to Q2 and nothing will be pushed onto the stack. That means what? Z0 is also popped off, because we have read Z0 means what? Z0 was popped off. That's why. So after apply this definition. We have read entire string. After reading entire string, starting from initial state, we have started from initial state now. Starting from initial state, entire string is read and stack becomes empty. See here carefully, stack becomes empty. So 4A and 4B string is accepted by this PDA. Okay, I hope I have made the point clear to all of you. So I have given you intuitive idea about how this PDA is working. Okay, let me show you one more question so that you will get more idea. Okay, so let me take 4 A's and 5 B's. Okay, that will give you more idea. 4 A's and 5 B's. Okay, so see here carefully. Obviously, this string will be rejected now, because this string is not in the language. In the language, we have strings equal A's followed by equal Bs. So 4As and 5Bs should be rejected. So see here why this string will be rejected by the given PDA. See here carefully. Okay. So what I will say now, I think you all remember these moves. So now this is very easy task for you. So we'll say Q naught. See, initially we have Z naught, Q naught A, Z naught, Q naught A, Z naught. Again here Q naught A, Q naught A. That means what we are blindly pushing all the A's again. So we have pushed. Now on Q naught, we are at Q naught. We have read B from the tape and we have read A from the stack. See here carefully. Q naught, we have read B from the tape. We have read A from the stack. See the move. Q naught. See here. Q naught B A Q1 null. So we will move to state Q1. Okay. So let me rub all these things so that it won't create any problem for us. Okay. So we will jump to state Q1 and nothing is pushed onto the stack. That means what? This A was popped off now because we have applied this move now. BA. See here carefully. Q naught BA Q1 null. So A was read from the stack. That means what? A was read after popping. So you have popped it and you are not pushing it again. So directly we have popped this A. Okay. So directly now we have started cutting. So Q1 BA cut. Q1 BA cut. See here carefully. Q1 BA cut. Okay. So we have done cutting. Now see here carefully. We are at Q1 and Z0 is read from the stack. See here carefully. As soon as we are at Q0 and Z0 is read from the stack, then PDA will behave like a small kid. It will become excited and it won't read this B from the tape. And it will make the stack empty and jump to state Q2. So please see here carefully. We have not read this B from the tape. So I will not jump or I will not go one position to the right, or read head will not go one position to the right. Read head will be placed on this B itself. Read head will be placed on this B itself and state will be changed to Q2. Okay. And this Z0 is popped off. Now you will say, sir, stack is empty. So string will be accepted, but we should reject it. No, string will be rejected. Why string will be rejected? Because see the definition carefully. Starting from initial state, after reading entire input string, null store must be empty. Second condition is after reading entire input string. Do you have read entire string? No, this B is left unread. That means what? We have not read the entire string. Hence, string will be rejected. Okay. So this is the way how we should say that string is rejected by this PDA. Okay. I hope I have made the point clear. So if number of B's are more, then I will say that entire string is not read by PDA and stack will become empty. Hence, string will be rejected. What if A's are? So let me show you here also. What if number of A's are more? So let me say 1, 2, 3, 4, 5 A's and say 4 B's. What will happen here? See here carefully. Initially we are at Z0. So Q0 A Z0, A Z0. Okay, Q0 A. So just push all the A's. 3 A's are pushed. Now again Q0 A, this A is pushed. Q0 A, this A is pushed. Again, see, I am just saving the time. Otherwise, I should say, okay, if I want to say properly, I have told you many times, but still, let me do it because this is your last example. So let me do it properly. Okay, let me do it properly for you. Okay, so I will do 1 or 2 moves properly. Okay, yeah. So I will say here carefully. We are at Q0. A is read from the tape, and Z0 is read from the stack. Since Z0 is read from the stack, so Z0 will be popped off. Okay, Z0 will be popped off. Okay, yeah, Z0 will be popped off. Now I will say, see the move, Q0 A Z0, Q0 A Z0. So Q0 we will jump to Q0, we will remain in Q0 only, and A Z0 will be pushed onto the stack. Okay, and why read head is moved 1 position to the right? Because we have read this A. That's why it has moved 1 position to the right. Now we are at Q0. A is read from the tape and this A is read from the stack. Since we have read this A from the stack, I will pop it. Now I will say Q0 A. See here, Q naught AA, that means what? Q naught double A. Double A means what? The A which you have popped off, you will push it, and the A which is read from the tape, you have to push it again. Now I am doing it in a faster manner. Q naught AA, AA. Q naught AA, AA. Q naught AA, AA. That means what? We have pushed all the A's onto the stack. Now Q naught BA, cutting will be done. We will jump to Q1 state. Okay, we will jump to Q1 state. Q1 BA cutting. Q1 BA cutting. Q1 BA cutting. Now what will you do now? Okay, so here we have nothing. So on Q1, we directly and indirectly we should say we are reading nothing from the tape and we are reading A from the stack. Where is the move? We do not have this move. On Q1 we are reading nothing from the tape and we are reading A from the stack. This move is absent. Only Z0 is allowed. Reading A is not allowed. That means what? The string will be rejected. Why? Because of dead configuration. DC means dead configuration. So Dpda, or you can say PDA, will halt in a non-final state. Or sorry, we should not say that non-final state. We will say that PDA will halt in dead configuration. Okay, there is no concept of final state in acceptance by null store. Okay, please note it down carefully. There is no concept of final state in case of null store. So we will say that PDA will halt in dead configuration, or directly indirectly you can say like this also. We have read entire string and stack is not empty. That's why string will be rejected. So there are lots and lots of ways of saying it. So I am saying that PDA will halt in dead configuration because we do not have move. Okay, or you can say it like this also. If you want to go strictly by definition, then you should say starting from initial state. We have starting from initial state. We have read the entire string, but stack is not empty. That means what? The string will be rejected. Okay, so this is the way. Okay, so please note it down carefully. I am putting everything on one slide so that you can note it down carefully. Okay, please, I think everything is visible to all of you. Please note it down carefully. So this is construction of PDA accepting L by null store. Okay, this is acceptance by null store. Please note it down carefully. Okay, so in case of null store, we do not have any you can say final concept of final state. Okay, yeah, and we have one more way. Okay, let me show you that also. We have one more way. Okay, we have one more way of showing this PDA. This is one way, that is delta move. This is known as delta moves. Okay, PDA delta moves. This is PDA by delta move. This PDA can be converted to state transition diagram also. STD, state transition diagram, just like FA, na? We can make STD also. So how I'm going to construct it? From here only I am going to construct. Please see carefully. I will say initial state is Q0. Q0 AZ0. So I will put here self loop because we are in Q0 only, na? So I will say A Z0 slash AZ0. It means what? We are at Q0. Okay, this move means what? See here carefully. This move means we are at Q0, read A from the tape, read Z0 from the stack, and we are going to push AZ0 onto the stack. Now again, Q0 AA, Q0 AA. So I will say here A double A. That's it. Now Q0 BA, Q1 null. So I will say Q0 BA null, and we will jump to Q1. Okay, I hope you are getting it. Now Q1 BA, Q1 null. So it is doing cutting now. So BA null. Okay, so what does this mean? BA null. So we are at Q1. PDA is at Q1. B is read from the tape. A is read from the stack, and then we have pushed nothing onto the stack. Okay, so if you are getting confused by this slash, then please do not get confused. I will write it properly. BA. Okay, it hardly matters. It is just representation, and every book has a different representation. So please do not get worried about all these things. Okay, so okay, but still, I think you should you all you all were getting confused. That's why I have written comma here, because here we have written comma, here we have written comma, na? So we should write here also comma. That means what, Q1 on reading B from tape, reading A from stack, we'll push nothing onto the stack. Okay, yeah. Now this move will keep on running, and after that on Q1, okay, on Q1 we will read nothing from the tape, and we will read Z0 from the stack, and we will jump to state Q2. That's it. Okay, yeah. So this is yeah, and null is pushed onto the stack. That means nothing is pushed onto the stack, na? So write here null also. Yeah. This is your final state transition diagram for your PDA or PDA accepting A parent, B parent, and is greater than equal to 0. Now see here carefully. Is this Dpda or NDPda? See here carefully. There is unique move in every case. Now see here carefully. We have unique move in every case. Okay, so condition number 2 is satisfied. We have two conditions. Now see here carefully. We have two conditions. There should be unique move for each sigma, tau, and q combination. Okay, so we have unique move, no problem at all. And one more condition was that if we have a true move, then null move should be absent, and if we have a null move, then true move should be absent. So see here carefully. You will get confused that, sir, see here, we have a null move now. So why we are having true move? See here carefully what I have exactly told you. For same state and same stack symbol, if we have a true move, then null move should be absent. Now see here carefully. Or state is Q1, stack symbol is Z0. We have a null move. So do we have any true move like this? Delta Q1 Z0, and here we are reading A or B. We do not have any move like this. See here carefully. We do not have Q1 BZ0 or Q1 AZ0 or Q1 BZ0 like this. We don't have any move like this. So there is no problem at all. This is perfect Dpda. Okay, this is and obviously if this is a Dpda, then obviously it is NDPda also. Okay, so no question on that, and no confusion in this concept. Okay, so okay, so if we have, see, the only thing which you need to concentrate is on null move. If you have a null move, then on the same state and on same stack symbol, you should not have a true move. This is the basic thing, because only that thing will make confusion now. So we are at Q1 reading Z0, stack from stack we are reading Z0, and we are reading nothing from the tape. Okay, and if we have a true move, then we will have a choice that on Q1, after reading Z0 from the stack, we have a choice that PDA got excited, that is, it is not reading anything, or PDA is not getting excited and it is reading something like this. See here carefully. If we write here move Q1 B Z0 is equal to, say, Q3 A. I am writing just it's not logical. I'm just writing it to get you an idea. Okay, so we are at Q1. After reading Z0 from the stack, there is a choice that if PDA get excited, that means it is reading nothing from the tape. It will go to Q2 and nothing will be pushed onto the stack. And here we are saying we are at same state Q1. We are reading Z0 from the stack. Now we are reading B from the tape. So what directly indirectly I am saying that on Q1, after reading Z0 from the stack, PDA has a choice that either it read nothing from the tape or it read B from the tape. Because of this choice, I will say that it is NDPda. But there is no choice as such here, so it is Dpda. Okay, I hope I have made the point clear to all of you. Yeah, now see here state transition diagram also. Okay, so that's it. This is all about construction of PDA accepting L by null store. What about my final state? Final state will be exactly same. The only thing will be we will make Q2 as final, that's it. Okay, and here we okay, let me do it for you properly. Okay, so see here, L is A parent, B parent, and is greater than equal to 1. Construct PDA accepting L by final state. So how will you do it? Similar idea, exactly similar idea. So I am directly making state transition diagram. Just try to visualize it. On Q0, if we read A and Z0 from the stack, we will push A Z0 onto the stack. On Q0, if we read A and we read A from the stack, this A means A from the tape, this A means A from the stack, and we are reading pushing double A onto the stack. That means what? Directly and indirectly we are pushing each and every A onto the stack. This move means what? We are pushing each and every A onto the stack. As soon as B comes and we are reading A from the stack, okay, then we will push nothing onto the stack. We will move to state, say Q1. On Q1 we will do cutting, that means be a null, and as soon as we read Z0 from the stack, then we will read nothing from the tape, and we have a choice. Either you put Z0 or you put null. It hardly matters to me. Okay, or let me put Z0 only. Okay, we will jump to state Q2 and we will make Q2 as final. That's it. This is the basic meaning of acceptance by final state. So the only thing which you are doing here is this. In case of PDA with null store, we are not making Q2 as final. We are just saying that we have made stack as empty. That's it. Okay, so if stack becomes empty, we are not concerned about state. We will say that PDA will accept the state. But in case of final state, we have to jump to final state. Okay, so we will jump to state Q2, which is our final. And see here, stack is not empty, because in case of final state, we are not concerned about stack. And in case of stack, we are not concerned about state. Please note it down carefully. These two are independent things. Since we are accepting by null store or by empty stack, we are not concerned about state. The state is not final. And in case of final state, we are not concerned about stack. Okay, stack may be empty, stack may not be empty, and so on. So this is your final PDA. Okay, yeah, and one more point is coming to my mind. See, I have made a new state Q2 now. In fact, I can make a self loop on Q1 also. That means what? Let me do it do it here. See, I can copy paste this PDA. Okay, let me copy paste it for you. Okay, so I think it will create a problem for us. Yeah, so this is your state transition diagram. Yeah, so let me now copy it. Oops. Oh, I think I'm not able to copy it. Let me do one more try. Okay, and then I have done it. Thankfully, I have done it. Yeah. So see here, I can delete this state also. Okay, we are not concerned about this. We can delete it. Okay, because we are not concerned about state, na. That's why I can keep this move here also. That means null Z0 null. So indirectly, I am saying that we can remain on Q1 also. Okay, so the only thing is stack must be empty. That's it. Okay, so here also in case of delta move also, I can put Q in place of Q0. In place of Q2, I can keep Q1 also. In case of null store, because we are not concerned about final state. This is very, very important thing. Please note it down carefully. So I am saying that these two PDAs are equivalent. PDA equivalent means what? These two are accepting same language. Okay, because we are not concerned about state, I am just saying that on Q1, as soon as you read Z0 from the stack, so you will read nothing from the tape and nothing will be pushed onto the stack. That means what? Stack will become empty. That's it. Please note it down carefully. Both are equivalent, and this is homework for you, that try this PDA, okay, for 3 strings. Okay, so first string will be, of course, equal A's equal B's, 4 A's and 4 B's. Second string will be number of A's are more than number of B's, 5 A's and 4 B's, and third will be 4 A's and 5 B's. Okay, try to run this PDA on these 3 strings. You will get more idea about why this PDA is correct. Okay, or why this new state Q2 is not required here. Okay? Yeah, but for final state, this is compulsion, because we have to go to final state now. Okay, for final state, this new state is compulsion. We cannot make a self loop here. Okay, please note it down here. Okay, yeah. So let me give you one more idea that why we cannot keep self loop here, because if we keep self loop here, then you have to make q1 as final, and if you make q1 as final, then it will accept other strings also. Okay, let me give you idea. Let me give you some idea. Okay, so if you make here self loop, that will create a very big problem for us. Okay, let me give you some idea, and then I will stop this lecture. I think it's getting longer and longer, but I want to give you idea. That's why I am doing it. Okay, so be a null q1, be a null, and null z0. If you make q1 as, because we are see, if we want to delete this state q2, then we should have a final state now, because we are accepting by final state. So we will keep this self loop here, null z0, and we will make q1 as final. Now it will create very big problem for us. Let me show you some idea. Okay, let me take some string. See, we take a string triple AB. Now what will happen, see here carefully. Okay, I'm not going to repeat it again and again. We will be at initially we will be at state q0, and q0, a is read from the tape, z0 is read from the stack. See the move, see the move. I think you already have noted down. So q0, the purpose of q0 is push each and every a. So I'm pushing every a in a faster manner. Now we are at q0 only. We have read b from the tape and a from the stack. See here carefully, very important point is coming. q0, b and a. See here, q0, b, a. Nothing is pushed onto the stack, and we are moving at q1. We are moving at q1. So what will I say? B and A are cut down, and we are at q1, and q1 is our final state. Now apply the definition. Starting from initial state, after reading entire input string, we have read entire input string. PDA is at any one of the final states. String will be accepted. That means what? Triple A B will be accepted, but it should not be accepted now, because number of A's are more than number of B's, but it will be accepted by this PDA. Hence, this is wrong. Okay, so the only way is you have to make a new final state. Okay, now please, this is homework for you. This video is getting longer and longer, so this is homework for you. Try to accept. I have given you idea, na? Try to accept triple A, triple B. Okay, and try to reject 4 A's and triple B, and try to reject triple A and 4 B's. Okay, this is homework for you. And if you are not able to follow, then from here itself I will resume the lecture. Okay, so most probably day after tomorrow I will make a new lecture, and I will tell you each and everything about this. Okay, yeah, so please note it down carefully. I have put everything on one slide. Okay, and from here only I will start the next lecture. Okay, thank you so much. Bye bye.